So for all of you early birds, there's a special announcement, which is this afternoon at 4 p.m. in this classroom, I'll be giving a special talk. I don't know that it was sent out, but I will invite you as my honored guests to come. And it's basically me talking about my career, some of my research projects over time, and how did I end up here anyway? Kind of story. So it's a little bit of Dan's life and a little bit of what it means to be a UX researcher, HCI researcher over the years. It's called something like 40 years. That's the original title. It was 40 years of doing HCI research. Yeah, it's sort of frightening. Anyway, let's get going because we've got a wonderful talk today. As you know, our special speaker is Ibrahim. I'm going to turn it over to him in 1 minute, but I want to start with the very first thing, which is our AI news of the day. And there's been so much news the past couple of days. I'm only going to give you one, just one, because it's so interesting, which is this article came out in Wall Street Journal this week, which is about the updates to car technology. It's trying to drive people nuts. And there was a big study done where the measure that people give about how understandable their car is has dropped by almost a factor of 50%. It's astounding. So if you would have asked this question, say 5 years ago, people would say, yeah, I understand my car works. I understand the controls. Now, roughly 50% of people say, I don't understand my car. I don't understand where the buttons are. And basically, it's a lot of things you think would improve the driving experience, like the heads-up display. A lot of people hate that. They just hate that. You might like it, but a lot of people hate it. Or the touch buttons that are on the touch screen. You can't feel them anymore, right? You have to actually take your eyes off the road and look, find it. And then if you're in a bumpy situation, like you're in the cobblestones or something, you have to do this and hopefully hit the right button. I don't know how many times I've hit the wrong button and gotten my radio music system into some weirdo state that I don't understand. And I have to back out of it, which means I had to pull over at once in order to fix it. So this is the too rapid introduction of inexplicable technology, which leads me perfectly to today's topic, which is explainability. I talked about this a little bit yesterday as a way of setting it up for Ibrahim. So let's get going. I'm going to give you 2 quick slides to set him up. This was a classic computer in the loop. Notice this plane. This is an X-29, forward swept wings. No human can fly it. You need a computer in the loop to fly it because the aerodynamics are so weird and unstable. Okay. Then there's human in the loop which is basically radiology systems that help radiologists do their thing. And we'll talk more about the upsides and downsides of that. But explainability is putting humans squarely in the loop. What's going on? Tell us, Ibrahim. I'm going to give the floor to you. I'm going to stop sharing my screen, and you should start sharing yours. Start sharing yours, yeah. And turn your microphone on. I'm going to go sit back in the back so I can see what it looks like. No seats over there.
Okay. Should I also turn on my camera, or can I?
Yeah, turn on your camera.
Okay. Just to know. Share screen. Okay. 1 second. Yeah. 1 second.
And your camera is on, your microphone is on, right?
Yes. Okay.
Showing eyes?
Yeah. Technology. Così.
Don't worry about it. I'll fix it in post.
No, wait. I will do this. I promise that I'm smart. Now with the technology. Now it's good. Okay. So hi everyone. I'm Ibra. Continue. Okay. Yes. Okay. I'm Ibra, one of the TA, and today, thanks to Dan, I'm going to give you the talk about explainability, and it's one of my core pillar of research. It is my first time giving a lecture about explainability, so feel free to interrupt me if something is unclear. I will try my best to answer your question. And if you wish that something would have been different, reach out to me at the end of the lecture because feedbacks are always great. Okay, artificial intelligence systems are becoming more and more complex. I don't know if you had any chance, like while interacting with an AI system or like even creating a model, and then you think, oh, nice that it's working, or no, it's not working. And then you're asking why these things is happening. So if this had happened to you in the past, you're not alone. A couple of days ago, I was scrolling Reddit and I found this screenshot that encapsulates exactly the problem that I'm trying to explain to you today. The user was asking other people why a specific show was recommending on our streaming services. And an explanation could actually have helped the user in understanding why this show was recommended to them. There are many definitions about explainability in academia. Every paper always comes with a new definition. But I decided to go back to the root, especially I opened a dictionary, the old book that some of you may know. And for example, the Oxford Dictionary of English defines explanation as a statement, a fact, situation that tells you why something has happened. In the AI context, so explanation could help us in closing the gap between the complex system and the human understanding. If we go back to the previous figure, someone could argue that actually there was already an explanation in this interface. It's true, and actually it's this one you may also like. Yes, maybe happy, but at the same time, user is still confused about the specific reason why this show has been recommended, which can cause the trust erosion in the system. So don't trust anymore in this case was a recommendation system. Moreover, the user cannot dive deep into in the model, understanding, okay, what actually my previous watching history has led to recommend this TV show. And lastly, there is no way for the user to provide any feedback, like I don't like this, I want a different thing. Okay. Setting the context, I will first introduce what is explainable AI by giving an overview. What may you're familiar with, what is the AI process. Usually everything starts with defining a task. So what problem we want to solve, what type of data we need to collect or we have already, and which machine learning we want to have. The second step is basically look into the data more in detail. So how we want to collect this data, how we want to clean and label, which brought us already to the first problem. So in the AI process, the first problem is about the data. But it also, we have a model problem because once we have this data, you have to decide which model you want to use, which feature to keep, how to train, how to evaluate, and lastly, in industry, when you deploy, and also how to monitor. So if we look to the entire AI process, we have a data phase or a data problem and a model phase or model problem. But that's not it. We also have a black box problem, especially if you are an end user, you're interacting with an AI system, you don't have any clue on why these things are happening. So it's quite magic. But it's also a double black box problem because you don't know which type of data have been collected, where, how they use it. So you don't even know the task formulation, most likely. So explanation can help the user, but also the model developer in making the first black box more transparent and giving a bit more information. So if we look to the definition of explainable AI, a narrow definition is basically all the techniques and method that makes the model decision understandable by people. But we can also define it more broadly. And in this case, it's everything that makes AI understandable, which include also the data, the function, performance, and uncertainty, and more. While explainable AI, it's like something very hot at the moment in the computer science field. Actually, it's been a while that it's around, since the 70s, 80s, where most of us were not born, so that is nice. But especially in 2010, what happened is that with the increased using of deep learning model, there was this interpretability crisis. So as we can see, like as the model become more and more complex, understanding what actually happened decrease, like it's impossible. Or increase actually the explanation. So one key event that has moved a lot of research towards explainable AI was in 2017, when DARPA created a suite of explainable machine learning techniques and in order to develop effective explanation interface. Why we need explanation and explainable AI? First of all, for scientific understanding, for extracting knowledge from the data, validating the consistency of the model, but also for safety. Models inherited our bias, so we should be able to detect this bias and finding when the system behave not well and try to fix it. Also from a legal, ethical, and societal consideration, we have to address discrimination. Now also the government use AI, so we have also to facilitate them to understand the decision-making that happen. On this aspect, the European Union is going hard. First with the AI Act, where they require that if a system is in a risk-based scenario, they should have different explanation requirements. They are obliged to be transparent, so disclosure when the user is interacting with the AI system, and if anything happened in post-market monitoring, people should be able to understand it. But before 2021, there was the GDPR and the right to explain, again, coming from the EU. In particular, there are three key articles. The first one is the 13, which states that information should be provided where personal data are collected from the subject. So this is most likely always the cookie that you have to accept or reject. Then there is the article 15, which is the right access to information about the logic involved. You should be able to ask how your data be used and what is behind the system you're interacting to. And lastly, the article 2022. The article 22. So if there is an AI system behind decision making, you should be aware of. I'm not sure that this happened because most of the time you don't know. Lastly, it's for practical system development. So from a computer scientist perspective, it can help you to debug the system, detecting if there is any data leakage, and enable improvement through feedback. Explainability is not only a computer science problem. If we look to psychology, also they look about explanation, in particular what constitutes a good explanation and how human process and evaluate explanation. It's an HCI problem, so how do we shape explanation interface? But it's also a social science problem, because explanation, if you think on how usually you do, it's very interactive, very human. You always have someone that ask a question, so try to have like an explanation and the other one replies. It's very interactive. And lastly, it's about law and ethics. So which ethical principle are required for transparency? Okay. When it comes to explainable AI, you have a lot of definition. I decided to give you a few just to make the things a bit clear. So you could have transparent model, where basically the model, it's already explainable by its structure. An example is like if you use a linear logistic regression, a decision tree, support vector machine, or k-nearest neighbor, these models are already transparent when you try to visualize, or even like by structuring the parameter. On the other side, there are the opaque model. So the model are not interpretable by their structure. Here we find again the decision tree, deep neural network, enforcement learning, and the lovely LLMs. And in this case, you could do post hoc explainability. So you generate the explanation once the model has been trained. Now I have a question for you, which is, do you have any idea why decision tree were both in transparent and in opaque model? Yes. You can decide one of the two.
I guess it's because like they do follow a clear logic in the sense of you have to make a choice based on some factor.
Mhm.
But it's not entirely clear why those decisions were set up to be made that way.
Almost. You want to try?
Maybe because you can kind of backtrack to the roots because of the tree structure.
Okay, and this will make like both of you like kind of make it to the transparent, but why are also opaque? So they're transparent, yes, because you can go back to the roots and basically try to understand the specific decision that decision tree has made. But they become not transparent because if you have like a super deep tree, it will be impossible to go back. So it's a matter of like how big the decision tree will become. Same for a support vector machine. Like if it's a simple model, it's easy to understand how the distinction is happening. But if it becomes huge and the problem, the data, then you will have difficulty to understand. Then explanation can be global. If we want to explain the model behavior across all the instances. Explanation could be cohort if you want to explain a subset of the prediction, such as like the 6 square out of the 16. Yes. Or could be local. So we want just to explain a specific instances. Lastly, we can have model-specific explanation. So the explainability model that you're using, it's tailored for the particular model architecture. So in this case, we have the AI model A. We use a specific XAI technique, and we receive an explanation. And for B, we are going to use a different XAI technique to have, again, an explanation for the model. Or could be model agnostic. So basically, you can apply the same technique independently of the model that you're using, and you will still receive the explanation. Lastly, explanation can take various forms. You could have feature attribution. So you're assigning importance scores to the input feature. We will see some of this later. Could be example-based. So you're looking to the training data and try to explain the training data why the output is the one of the model. There you have rule-based explanation, so expressing the model behavior as a decision rule. And lastly, you can have counterfactual explanation. So you're describing what you would need to change for having a different outcome. So how we can actually explain in a more practical way, so not just theoretically. I'm focusing only on post-hoc explanation. And if we look to feature attribution method, we are trying, as I said, to assign importance score to the input feature. There are two main techniques. The first one is LIME, which means locally interpretable model agnostic explanation. And it tries to approximate a complex model using a simple and interpretable model. What does it mean? So if we are training a model about predicting if a person will or will not have diabetes, we train our model using any deep learning technique that we want, and then we apply LIME. And basically, LIME will give us the model prediction on your left here. Then we can see the future contribution, so which future actually influenced the output, so if the user will have a diabetes or not. And then we see the exactly value for each feature. So in this case, we can see that the user will have a 72% probability that will have diabetes. And the reason that made the model have this decision is because of the glucose level, which is more than 99. The blood pressure, it's more than 70. Yes. Is it true? Yes. Okay. The second technique that you can use is SHAP, which is Shapley additive explanation, are based on Shapley value. That comes from game theory. It's always a bit of a mystery, the game theory, so do not ask questions about game theory for me. And they provide an unique attribution solution that satisfy particular properties. More broadly, you can think about Shapley value on how much each piece of information influenced the decision. It's already like, if we took the same example as before about the diabetes, you can always ask to plot, and you will see the feature ranked by their absolute value. So we see again the glucose, which also LIME was saying, and the model prediction about the value of the SHAP. Then the second type of positive explanation is about example-based. In this case, we select a particular instance of the data set and to explain the behavior of the machine learning model. It works pretty well if you have images of text because they contain a lot of contextual information, and this helps to understand why. So if we look to the example here, do you have any idea on why, if we ask to explain this image, then the model will provide us these planes as similar image? Yeah.
There's a sky in the background, and the object dark on the back.
Yep.
There's sharp lines. Kind of.
Yes. So in this case, like, it's a bird, but the fact that it's in the dark makes the model think that actually it's a plane. So not very smart, but it works. And lastly, we have counterfactual explanation, which help. They're gonna tell you how an instances needs to change to make the prediction different. So you can think of like, if X has not occurred, Y will not have occurred. Are very human friendly, very similar to maybe on how we reason about specific output. There is only one requirement, is that the counterfactual should be, the counterfactual instances should produce the predefined prediction as closely as possible. So if we look to an example, if we train a support vector machine to predict if a woman has a good credit risk, and let's say that the output is 24.2%, counterfactual can help us to answer the question how this input feature should be changed to get a prediction score higher than 50%. And in this case, we will see that in order to make the score higher than 50%, the woman should become skilled instead of unskilled, which we can see here. Then when applying, she would have to reduce the duration of the loan. She asked for 48, but it would be to go to 23 or 24. But then also the explanation that suggests that actually the woman should change the gender from female to male, which give us already and highlights that explanation can help us to find the gender bias in the model. Special part about large language model, since everyone or like a lot of research is happening, how we can explain this. And the idea is to use the chain of thoughts, which is an approach that simulates how human reason by breaking down complex tasks into a logic step towards a final solution. So while large language model seems that you give a prompt and you have an output, almost like magic, by using the chain of thoughts, you can see how the input and each of these steps the large language model is doing leads to the output, and you can increase until you have a tree of thoughts when you can also highlight the different part. Okay, I think I'm going fast, but because I've planned the break now, but we'll do later after this. So what is the role of the human in all of this? Understanding how human process explanation is actually crucial for designing effective explainable AI system. So if we look to the cognitive process of how humans perceive explanation, causal explanation are the one that we are most like human are most interested into, because they prefer to understand the mechanism rather than the correlation that leads to a specific output. Moreover, if you understand the mechanism, you will gain knowledge that you can transfer to different problems. Then we have complexity versus simplicity. In general, humans prefer simple explanation. And it is here where the Occam razor can help us in understanding and selecting the simple explanation. However, there is a problem if you have a complex system and you try to oversimplify the explanation. You may leave out some information that are important, and you reduce the satisfaction and trust of the user because they are still like unclear why things are happening. So you will need to find like an optimal complexity between the user expertise and the task that the user needs to solve. Some research have actually, they call the oversimplified explanation white lies, because it leads the user to have a wrong idea on how the machine learning model is working. Format has an impact on our cognitive process. You can have visual explanation, but also verbal explanation, such as in the case that I showed Reddit, you had like a sentence. These two types activate different cognitive process. Interaction helps. In the end, the explanation is like something interacting, even if you look to the human when you're asking explanation. And narrative can help in making complex explanation more accessible. So if we look to visual explanation, these are coming from explainable recommender system. You can see that there are many ways that you can help the user in understanding why a specific things that happen. So if we take the example on your right, so this one, basically we are going to use some slider where the user can understand based on their social profile and their connection why they should connect to companies or other person, and they see the relevance of each of the feature by how much the bar in the slider is connected. Or here it's about explaining the music recommendation. The user can set up their preferences, and they see in the space why the popularity of the song they recommended and play it. While academia goes a lot on the visualization, if we look to what industry is doing, it's basically text. It's a template. People are not very happy, at least the one that I had in a workshop. So if you took Apple Music, they generate a playlist for you, or for me in this case, and they set songs to help you relax and unwind, update every Sunday. Okay, not clear how this song has been selected. Netflix try a bit harder, and it says we think you will like this show because you watch a documentary. Or Zalando, they will suggest what type of size you need to buy based on the history. But interacting with the AI system has also like a trust aspect, and it needs to be understood to design explanation. And this trust, when you interact with an AI system, it's built on several stages. First of all, you have the initial trust formation. So the first impression of how people see the system, if there is a reputation because a friend of friend recommended to you or was in the news, would help to set up the stage. You have trust calibration as a second step. So you would need to adjust the trust based on the performance and if the system provides an explanation. And there is trust maintenance as a third step. So if the user, by interacting with the system, reinforce the sense of trust, or actually by using you're not happy and you can drop the system. And lastly, you have a part of trust repair. So you're recovering from the systems try to recover from this trust violation. And in this case, you can use explanation or interaction. Okay, I will do the break here actually. I'm going back to the break. I will do 5, it's okay.
Yes.
Oh, God.
Yeah.
But it's not.
You got 5 minutes.
Good to know. Hey,
Hey.
I have like a question of mine in the slide of the counterfactual.
Yeah.
About the gender bias.
Yeah.
I'm not really sure. Maybe it's like super obvious, but I'm not really sure why it's biased, actually.
Because counterfactual will basically say what you should need to change to increase the prediction score higher than 50.
Yeah.
And since, like, imagine the scenario, there is a woman go to the bank, they use the model and they're like, oh, to make it, then you're asking, okay, how can I make it higher? How can I have actually be sure that I receive the loan? And they're like, oh, actually you should change your gender. But this is impossible. But the model, based on the data that the model is trained on, it's already biased to men, because if you look to the score of men, it's higher, especially in this case. It's much higher compared to what it could be to a woman to receive the loan.
But these are facts, and actually men return the debt more successfully than women. Like, really they do. Would it be, I mean, the explanation is not biased then. It's like totally right.
Yes,
I
but
mean, maybe the world, society
exactly,
is biased, but,
yeah. But
but
this
the
is
explanation is totally fine.
the explanation. Yes, it's fine, but the explanation shows you that there is a bias in the model, which comes, of course, from the society.
Okay. Yeah, okay. Yeah, I get it.
I convinced you, no? Yes.
You want the explanation to explain the model, not to explain you whether there's a bias or not. Don't you?
Yes, but in this case, like here, yes, you're explaining the model, so you can give like tips to the woman on how actually to make it successful.
I mean, I'm really sure if you want tips, I mean, you just want to explain the model, isn't it? I mean, you don't want tips to make it to have a better, like a higher probability. That's the thing that you make use for, that you don't, explanation is like basically explain.
Yes, but then it's like, if we are this woman and you go to the bank says, we are not going to give you the credit loan because of the model says 24.2%. Yeah, the question would be, okay, what should I do to have the loan? And then like, okay, to have the loan, become a skilled worker, reduce the...
Yeah, I understand. Still, there is no solution then. I mean, there is no explanation that would show you, okay, there is this society where then there is no bias, so maybe if you try there, they will give you the loan.
I think it's
Unsolved problem.
It's an unsolved problem, yes, but also because like everything depends on how the society is built.
Okay.
So explanation can help to see this problem and then say, okay, how we can solve it. And you should go back to the data that you collected.
Yeah, but still the data that you collected is not biased in a way.
They're biased already.
Yeah, they're biased already, but not related to gender, because maybe it is real that men were doing.
Yeah, because like it's a society based on men that, like, it's a root problem, and it's based then on the fact that on how the data were collected.
Perfect. Thanks.
Well,
So we'll talk more about your lecture afterwards. That's all right. One minor tweak, a little bit louder.
Okay.
I'm sitting in the back row. It's a little hard to read.
Okay.
It's a little hard to hear, but otherwise great. Good.
Yeah, like I always present too fast.
Yeah, I mean that's another thing to say is you're speaking very quickly. You might consider repeating some segments.
Okay.
Just go back and say, you saw insight, whatever. Just because a repetition like that, because this is the first time they've ever heard this.
Yeah.
It's the 20th time you've
Yeah.
So what seems obvious to you may not be obvious to them.
Okay.
Otherwise, great. Keep it up.
Oh, yeah. Stuff like that.
I mean, like, if I stand you,
Vabbè, vamos a fare una cosa, ma...
And also, don't worry about ending soon. I'll just take over at the end.
Okay.
Switch computer.
no, it's the same.
You just
Maybe we're just like scared of the device.
And it just didn't.
But just without
It's
yeah, right. I didn't just
it's like widely multiple. Like
you know.
like it's never
Yeah.
at all. Like all gets like
Yeah.
50
Mm.
stuff.
Oh, that's what.
Yeah, I want to go to Singapore.
That's fair.
Is uppercase T and lowercase P?
Yeah.
Yeah, I understand it.
Okay. Let's continue. Okay, we have looked to what is explainable AI, what is the role of the human, how we can combine it. So how we can go through the human-centered explainable AI. Coming back to the AI process, we saw that it was a data and model problem. It was a black box problem, double black box problem. It's also another problem. It's a people problem. In every step, actually, people are actively involved by the task formulation, where there is someone that decided what to do, to even the model, where a model developer is training, setting the parameter, providing biases, everything is there. So we said the explanation can help us in understanding what happened to the model, and explanation are for the people. Usually, these explanations are most targeting the model developer, leaving out a complete group of people that actually actively use this model. So it's here where user-centered design can help us, because it needs to go for explainable AI, because it needs to go behind basic usability to address the unique challenges of the explanation, the human interaction with the system, and interface design. In particular, we can say the user-centered design are essential for creating explanation that meet actually the user need rather than what the developer assumed that the user want. So if we go back and look to the commercial application, because they're the one that most of you interact with, these type of explanation are always provided by the thought of the model developer, what they think you may need for an explanation. Of course, like they always go and ask people, they just not invent, but it's difficult to address all the needs of the user. So user experience design principle can be applied to explain explainable AI and its interface. So you could use purpose-driven design, which basically it's align the explanation to what user wants. You could look to cognitive load management, again, between simplicity and complexity, and trying to find the balance based on who is your user. So if you have a doctor, maybe they want explanation full of detail because they also have higher knowledge. But if you are a user of a smartwatch and you want some explanation, I don't need to go. I don't want to have such a medical knowledge because it would be ununderstandable for me. One UX principle that you can use is progressive disclosure. So basically you're revealing information step by step so that the user can build the knowledge, feel uncomfortable, and can help also with the cognitive load. Interaction design, always it's your friend. With LLMs, there is always a possibility to dialogue and asking further questions, dive deeper into the process, or even explore more. And then there is emotional design, where explanation could also consider everything that relates to the effective aspect of the explanation. Of course, when it comes to explaining, you also need to know a bit why you're explaining, what is the purpose of your explanation. So there are many taxonomy about the explanation code. I took one that I think incorporates most of the aspect. So you could explain for transparency, so enable the user to understand how the system works. I would say this is the basic step of explanation. To justify, so validating the system logic, so proving that the system was working correctly. To give control to the user, and that they can learn how to influence the process, similar to the example where you had the Spotify recommendation before. You had this toggle at the top that you can adjust based on your preferences, and the model will reflect it. To improve, to identify a way to enhance the system. And lastly, for relevance. So again, similarly, to understand why information is presented to the user. You could use co-design approaches. As I mentioned, it's very much needed that you understand who is your user. So you could go and talk with the stakeholder and understand, okay, you have this process, where in the process you need explanation, and also what type of explanation you would expect it. So you take all these people together and you start talking to them to collect what are their needs, what the system requirements. Then you could try to have a Wizard of Oz that you're doing now to test the explanation concept even before implementing. It could be at the beginning a bit cost because you're investing time to do like another experiment, but in the long term could provide you benefit because you already know that the thing should work fine. And lastly is to do a contextual analysis. So observing existing explanation and understand what they work, what doesn't work, pain point, asking user to interact, to understand. From a development part, you can have different patterns when it comes to explainability. You could build a dashboard where basically you create this interactive UI that combines different type of explanation, and the user can interact, can explore the data that they have, the model parameter. I will show you an example later. You can have an interactive what-if analysis, which is going through the counterfactual explanation direction. So you build a tool that allows the user to explore the model behavior by tweaking the parameter, and then you can spot, okay, something is not working. We are just going through. We have bias that we keep propagate and so on. You can have comparative explanation. So you have a model, you provide two different output, so the user can understand, I will use always the recommendation because it's on my research agenda. Let's say that we are looking to buy a TV. The model recommends one TV, but also you can contrast a second one and say, these are the two best for different reasons. Or you could use narrative. It's a really powerful method that you can use and gives you like a way to the user to structure a logical flow of the model and builds on top of the knowledge so that you're not overwhelmed. So example for you about what-if analysis, this comes from Google Pair. So they have built an interactive UI for help the user understanding how the model behave when it comes to classify face detection, a smile actually, or it should be VIP people. And what happened is that the user is allowed to try different threshold and performance metrics. And you have like here on the top, you have all the toggle. I was like, I want to check just the young people. They're wearing wearing a hat, and basically the system already classified, and you have people smiling in the top and not smiling at the bottom. It seems that everyone that smiles doesn't wear a hat, so I don't know. Could be a correlation or causation. But also you have the option to do counterfactual. So I was like, okay, if I select this woman, what is the counterfactual value? And you can see it's exactly on the opposite side. She was smiling, she was not smiling, and then you can look to the different parameter of the model. I have an exercise for you now. For 10 minutes, I will ask you to think with your partner, with the people around you about a healthcare XAI tool. In particular, what I would like to hear from you is like, what could be the possible requirements? Yes, you can work.
So what explain more
So that's hard.
Yeah. I mean, but maybe like, I feel like I think that, like,
I think it is that. Yeah.
I feel more like
it's like
It's like-
something that's like
Yeah, that is it.
like it's like a civic service course that education duties. Like exactly diagnosis. This is exactly diagnosis.
yes, let's see the like.
Oh, yeah. It's like the door with the-
Yeah, yeah.
And then we have like this kind
Ignore that.
That's oh yeah.
You can get like a usually the answer is for every.
But actually,
But they can see like
Yeah,
yeah, I guess something like.
yeah, it's like some food fake guys.
Or like, you have like percentage of.
Yes, yes, that
And maybe like. Five. There's like this percentage of certain.
I guess. Yes.
Like right now, maybe they're
I'm not sure. I'm not sure.
It's kind of like.
I just registered for this last week. I always did it in progress.
On Ola.
All that.
Yeah, I think in progress means that actually the course is running now. I never have used OLAP as a student.
But I can't get in any material or any.
Yeah, because everything is like Because everything is on this side.
So of course not use all that.
No.
Okay.
Is your email?
That's it.
This one?
Yeah. So this course not use all that at all.
Everything is like it's a Google Doc where basically you can see the slides, the different assignment,
Yep.
the readings that you're asked to read a bit before the lecture to have like a complete overview. It's everything. It's in this document.
All right. Thank you.
The other one there's another one that they call Swiss Air works with the one
Okay. Who would like to share with us the requirements that they have taught? Any group? There is not right or wrong, so. Yep. Okay. Mhm.
Sometimes it's not, you're not quite sure how to stress. So I think, like, I mean, in her instance, I don't know government watch, but she was telling me that sometimes, like, when she pours a watch, she has to look at how it actually got the information.
Okay.
So I guess, why does the user have to, you know, go out of their way and read something?
And yeah. And if you think about like how you would explain to the user how to read, understand the stress score, any idea on how you would do that?
Also, which I thought in the feature differently.
Mhm.
For the name of that, it's very self-explanatory, so I think that then it's a lot of understanding. It works like the body better. I think that's like a which is it's straightforward, but I want to know how exactly it's behind put the name differently. So we ended the discussion with like if we provide extra information on the app itself, wouldn't that actually help the user if they're not tech savvy? They're just like a user. Wouldn't that be extra cognitive development tool? So it's kind of like how much we put it for example.
Maybe we want to know because we're computer science.
Yeah. Okay. Like on the cognitive level, yes, would be a bit more work for the user. But in the end, like if you provide this explanation, like just for the people that want to know, so they know, oh, I want to know, I go to the app and read it. I don't see the cognitive load because they actively are looking for the information. Like if you provide instead to everyone, independently if they want to know the explanation or not, that in that case, yes, the user is required to have a bit more.
Whenever I start eating, I feel like maybe whenever type of hair can go off my arm, like putting or whatever different position, it sends me that reminder, tell me to relax.
Okay.
So it's their word ask. But I guess that is where triggered me, like, why did you tell me that?
Okay.
Get a strong vibration. Much.
Yeah.
I totally agree. I want my data. I'm open to it.
Definitely. Any other group that want to share their discussion? Yeah.
Also, that in terms of data protection, access the data, have the data, how from their data.
And what would you say is the main difference between the stakeholder? Like if you're considering the doctor of a lay user.
For the doctor, like you then like
Any other person from the middle? Yeah, to the back again.
I'm not sure it's really, but a system where you could symptoms and just give you suggestions for a course of action, and thinking that the system or the AI should be kind of deterministic, A/B counter. Because when I say like I have a headache and the system suggests to take a pill, and 2 weeks later I have the same symptoms and it just says drink water. As a user, I would be confused, like where's the difference of what symptoms. So yeah, this context should be deterministic. The AI.
But question for you. Then how would you, like if you're the user, the first time it says, okay, take paracetamol. The second time it says drink water. Then how would you explain why drink water the second time?
From a system?
Yeah.
Well, the way we saw it is it should suggest water the second time, because we already started with paracetamol.
Mm-hmm.
That can be, I'm sure. If I just say I have a headache, why take paracetamol one time? So I think that should be the output of the system.
Okay. But then like, where is the explanation for the user?
The explanation.
Yeah.
That's like, it's understandable for the that the suggestions are thing. System explains the suggestions in the same way.
So you will provide more context. Like if the system suggests drink water, you would add more context to understand, for the user to understand why this time they will need to drink water instead of taking paracetamol. Or would you say that drinking water it's already wrong and the user should be able to say no, it's wrong to drink water?
Okay, so the change that should a whole explanation on, or like the system should remember, hey, last time I said paracetamol, but like this time maybe just try water first and then hours sometimes. But the explanation should be longer.
Yeah.
A friend-end tool which can take data from your wearable devices, fitness devices, and also can take reports of your medical tests. And it should have a chatbot where you can keep history of your diagnosis. And as per that, it can you can chat with it, tell your symptoms, and based on your history and report, would suggest you the diagnosis.
It seems that a lot of you are thinking about explaining with just text. Has anyone thought about explaining via visualization?
We thought of something similar to one of the slides before, where it's like if you get a diagnosis by this tool, then it would show you by, I don't know, a slider which factors contributed to that diagnosis. So if it's, I don't know, cancer, then you can see like like why does the system think it's that, which factors contributed, and also maybe it could show like the certainty level. So like if it's sure by 60% or 90%.
And it would be for the doctor, for the clinician, or for the patient?
For the both actually, because like the patient could see what are the factors, and then if they would go to the doctor to like kind of confirm that he could say like this is what the tool told me,
Mhm.
what's the reasoning for that.
So we would use the expert to validation.
Yeah.
Deep learning don't really know what the thing is doing, and explaining why this result is there is quite hard.
Mhm.
So I would say it's not really explainable. And then you have to go to an expert, and then he runs some tests and tests are more explainable than like the actual result.
Any last one that want to share? No? Okay. So then comes the big question, how we can evaluate the explanation that we provide to the user. Spoiler, it's very complicated. It's complicated because it's very subjective. Each one of us has a different idea of what a good explanation is. So what for me could be good, for one of you could be awful, and vice versa. So you could have some evaluation criteria. So for example, you could look on how good the explanation reflects the model behavior. If you have access and you're a model developer, you can actually state that. You can ask the user how understandable was the explanation, and then ask to rank between 1 to 5 in a Likert scale. If the explanation support like a decision-making process, you can ask, okay, are you making a decision better? If the user is satisfied on the explanation, and this actually has an effect on the trust towards the system. And then you can also look to the efficiency, coming back to the cognitive load and computational load of the explanation. So how we can actually do this? You could do a functional testing. So you're looking if the explanation produced the expected output. So you're training a model, you have an idea of how the model works, and then you're like, okay, the explanation should also reflect this way of thinking. You could do technical validation. So if you have knowledge about the math behind and checking if the explanation reflected, you can go and ask human to say, does this explanation make sense? Hopefully they say yes. And then you can look to application and check if the performance of a specific task that you ask the user to solve improve or not by adding an explanation. But you should not wait the end of the process to investigate and evaluate your explanation. You can actually have the evaluation process throughout the entire explainability life cycle. Once again, identify the explanation needs before implementing. It helps. You could do iterative testing. We said the Wizard of Oz. It's a nice step to do it. You can even do sketches. You do session with the user. If you're building an interface and you want graphical explanation, understanding how they would kind of interact with it. After you deploy the system, do like a summary evaluation to see, okay, there is an improvement of the user decision making or not. And then one thing that's very difficult in academia is actually to check the explanation in a long time period. So if deployed something, keep track of it. But you can also have human-centered evaluation on how explanation affect the understanding and the user and the decision making. So you could check the mental model assessment. For example, you can have some prediction task. So can the user predict the model behavior in a new situation? So I take your example. Let's say that you're building the tool for just the clinician. What happens if instead of the clinician, we have the user? Will I still be able to use the tool or not? An explanation is helping them to understand the model or not. You can have conceptual understanding. So you ask the user to describe how the model works. And then you can have, for example, knowledge transfer. So if now I have an understanding in the clinical, and I know that I'm moving to the financial sector and they're using the same model, can I kind of understand how the model will work? Then explanations should, in the end, improve the task performance. So you can have some metrics on there. Decision quality, so accuracy, prediction, recall, if you look to the model side, but you can ask this question also to the human. So even like, are you happier with the decision that you make? How accurate you are the decision? Decision time, does the user takes more time to make the decision if an explanation it's provided or less? Sometimes it's more because you're requiring people to read and understand. Workload, again, you can track how much the user is stressed when you provide so much information. And actually, this is something very crucial because previous research has shown that if you have a lot of explanation and very complex, users feel more stressed, and then they drop like the decision and prefer like to go to simple or even pick randomly. Trust, we mentioned before, you have different phases for trust. And also in this case, you can track and the trust of the user towards the system. So you can look to the agreement rate. If we take the example for recommendation system, and we're using a streaming service, how many times the user agree with the recommendation, if an explanation is based or they do not agree. And also you can track the confidence of the user in the specific prediction. Lastly, we have contextual evaluation. So this is much related to have a longitudinal evaluation. You should check the learning curve. What happens when you're building a system that may have a lot of tools that you can tweak in for the model, you have explanation. User can be overwhelmed in the beginning and they have a learning curve to do. The retention, like if they keep coming back to the tool or like they used once, but it was too complicated and they decided to move to another one. And again, like I think observing the world, it's a great thing to do because you can learn a lot on how people behave. So what the future of explainability reserve? Of course, LLMs are everywhere. Why? Natural language generation can translate technical model into conversation. People can interact with it, so they ask follow-up question if a specific thing is not clear. They have a lot of knowledge, which can bring the contextual factor into play, so they can have memory to say, coming back to the example of the headache, maybe the user has provided like contextual, and I went drinking, so of course you drink water. You do not take paracetamol, or you have a busy day in the office, maybe paracetamol is the way to go. I have an example that Dan has made yesterday. So he asked Gemini to find great lasagna recipe on the internet. And Gemini suggests 3 recipes. I'm Italian, but I didn't open the link, so I will not judge. And then he asked why these 3 recommendations have been made. And Gemini reply about relevance. So he look for best and great, because then ask for great lasagna recipe, popularity and ratings. So the popularity of the website, if the user provide a rating because they tried the recipe. Diversity, questionable. There is only one recipe for lasagna. And quality of information. So they look to the clarity, recipe, if there were detailed ingredient, and so on. So it says, essentially, I try to act as a sous chef, sitting to the vast amount of information available and presenting with the most promising opinion based on your request. I think, what do you think? It's a good explanation. If you ask why you're recommending 3 websites for a lasagna, would you change something? Would you expect something different? Yep.
Maybe it depends who I am. So if I'm like a person who's not techie, then this maybe would be sufficient. But maybe if I'm techie, then I would need more information on how the model itself works. So I think it kind of depends on how much I want.
Yep. This is true, and this is also where LLMs, or in general chatbot, can help, because then you're like, okay, actually, I'm a computer science geek. I want to know more exactly on, I don't know, the ranking algorithm that you pick up. And maybe Gemini will give you the answer. I don't know. Any other thoughts? Yep.
You think it's actually built in explainability functionality Gemini, or just like another LLM output? Basically says what you want.
This is a good question. I think it's the second one. Of course, like, it provides you a bit of like maybe the reasoning. I think maybe a chain of thoughts here would be helpful, because then you can see exactly what the process was to lead to these 3 last recommendation. But it was something that I was discussing with them yesterday, and I think in the end is something that you were expecting to read to make you happy. So the satisfaction, it's high. I don't know if I will completely trust this, especially because when then was like asking Gemini, it put like the reasoning process. So I would expect it to see the exact step and not just hearing what I want like to hear. But it was a good question. Of course, LLM are not the solution to everything. They're great sometimes. So there comes a lot of challenges. The first one is that even in the explanation, you have hallucination. And it's very tricky at the moment to judge if the explanation is sound or it's like just something random that is something they would expect it to hear, and then you're happy. Going with text, you have the problem of oversimplify. Again, you have to balance it in terms of like technical detail. And again, it depends on who is your user. So this is why it's very important to ask, if you have in mind who is your stakeholder, what are their needs. Or even like with the chatbot, provide, okay, you know, like I'm Ibra, I'm a PhD. This is my background knowledge. Give me now the explanation based on my profile. Evaluation, very big topic. And then implementation complexity. So you have already a complex system, and you're trying to explain the complex system via another complex system. So it's a good recipe, not sure. The second future direction is about personalized explanation. It's something that we have talked already. Explanations should be tailored to you. If, like in the example that I provide you from the industry, most of the time is a template explanation. It's always like based on other people. We don't know who other people are, or we think you will like it. Yes, but are very impersonal. So this could help in the cognitive style adaptation, so matching the explanation to the user model, providing more context, emotional reaction to the explanation, especially maybe if you're looking for a movie or you're listening to songs, and then you have like the AI system, there are commands, and maybe can tailor the explanation, or you look very happy or you look very sad, and try to guide you. And again, interactivity. I think LLMs enable a lot of interactivity, but I think even storytelling, it's a nice way to explain complex models, but also like interacting via visualization. The thing that we a bit introduce is about the register and the tone of the explanation. So the linguistic characteristics of the explanation have an impact on the effectiveness across the audience we're referring to and the context. Again, we have technical versus conversational. If we bring the example of healthcare, if you're talking, like if the explanation is for the doctor, could be very technical. But then if it's like for a lay user, maybe it's better to have a conversation, keep it simple. I don't know, every time, even if you think when you go to a doctor and they start using jargon, I'm like, I haven't studied medicine, so keep it simple, write everything down because I will forget in 2 seconds. If there is any domain-specific terminology, you should have it, and the explanation should include it. Again, it's always based on the user. And narrative, I will show you 2 examples later based on my research. I think it's a great way to enhance this user comprehension of the complex system. Multimodal explanation. I told you you can use text, you can use visual, you can even combine it and say, okay, I have a visual explanation, I want text, or I have a text explanation, I want visual, based on like how you prefer to look at it. Stats are nice, but you forget the number. Have a story, you remember. And then you can even abstract. So you can go from one specific case and then try to give the explanation of how the entire model works. Lastly, very big topic is about human AI collaboration. And I think even in explanation, you can have this collaboration. You can have interface where both agents collaborate, and maybe the human provide the knowledge and the AI use this knowledge to make the explanation complete. You can co-create the explanation together, and knowledge integration. Yes. Okay, last slide about my research and why I'm putting my research in the explainability lecture. So I'm working on explaining recommendation system such as Spotify, Netflix, any. But I'm trying to make it human somehow. So as you have may guess, like systems are becoming more complex. An explanation for this specific domain sometimes fails to capture this complexity. So most of the time you watch X, we recommended Y, or we made this for you. And basically, even if you are a lay user, this explanation fails to convey the underlying algorithm complexity. Could even be like, you have listened to a particular artist, and then you're recommending me a different one. Or you have listened to one song, and this is very similar, I'm recommending this other song. So it's not technical, but at least it gives a bit of layer of complexity to user back. They lack contextual relevance. It's always one size fits all. Based on my experiment, people actually ignore that the explanation is there because where it's positioned in the UI, it's difficult to spot. It's text. User don't care. And are static. User cannot interact to know more. So what I'm doing, I have a bit of design background, and I'm using one design approach called data humanism. They will come from the information design field, where basically the idea is to reconnect the fact that data are actually produced by human, are not perfect, and we have to recall that behind a number there is always someone, a real person. So trying to bring human story to the forefront, create meaningful emotional visualization, emphasize context, narrative, and lastly, even if the things are complex, user, if they spend time with the data, they will appreciate the complexity, because most of the time it's your own data that has been used, and it's good to give it back. I will present two examples. The first one is surely POI, where we have used a narrative-driven, approach to build an interactive recommender system for point of interest. And in this case, you will see that the user, interact with the storytelling approach. So we contextualize the point of interest in Zurich. We ask the user, I'm selecting a pizzeria. We ask the user to recall place. These data were coming from the city of Zurich, about restaurant. Can I speed up a bit? Whoop. Yeah. Sports activity. So for some category, bars and pubs. So every time we first contextualize the point on the map, and then we ask the user to reflect on what they like. This was to solve like a problem of recommendation system. Some bars are not there, but it's not my fault. It's because of the data. It's because of the data. They exist. Museum and gallery. Okay. No, sorry. I just want to move it. Yeah. One. Yep. Then basically what we have done was to provide the user with some explanation already on how the model perceives the preferences. So that user can understand, oh, actually the model has created a good profile of me or not. So at the top, we have a stacked bar chart for the category with the percentage based on the selection. So 9% of the point of interest I selected were tagged as atmosphere. And at the bottom, we have a word cloud that basically from the description, we extract just the keyword so the user understands. Okay. Then what happens is that you have the classic map. You have at the top the place you visit. You can go back and explore more. So culture would make sense. And then you save, and you have the recommendation. And here you are doing an explanation. So basically, you can check how aligned the recommendation were with your preferences. Yeah, you're checking restaurant. Yeah. Then what happened was like, user always believed that the output of a model is perfect. So we wanted to include this imperfection with the model accurate confidence. So we encoded with the area of the point, the likelihood that the model thinks the user will like a specific place. And lastly, to showcase that the model are complex and it's not magic, user can activate a third layer and basically it's similarity between the point of interest and can explore the impact of your input to the output. Yes. The second project, which is under review, we try to explain song recommendation. In particular, one student of mine asked Spotify its own data. So we received 10 years of data. We try to contextualize and have like a transparent recommendation process. So what happened is that, so this is the main view. You have each of these glyphs is a song, and each of the line represents if the user has never skipped a song, if they skip the song after a couple of seconds, if they skip the song more in the process, and everything is contextualized. So there was a moment where he was obsessed with ABBA, then we were studying. Yes. So this is just 1 week. Let's say that we are in the mood for ABBA song. So what you can do is to select all the songs in the range of the ABBA. Then you'd say, okay, I want recommendation. It takes a bit of time, but recommendation will show up. Okay. So what happens is that you have a recap of the song you have selected on the left, and then you have the recommendation. You have the similarity score between the aggregate song and the song they recommend. And then here you have a big glyph of the aggregated song. What happens is that you can scroll, you can see like the impact, the recommendation impact, the amount listened, the genre. Pop, it's the genre that was most. Then if you select one of the recommended song, what happens is that we overlay the feature of the song on the aggregated one. And you can see that a specific feature has a complete overlay. Here we're missing one. Here actually we have one more. You still have the similarity score, and you can see more of the feature of the song and how they compare. And with that, I finish. I will give back the floor to Dan. Yes, and then here all the references. Yes.
Why is it useful for the user to understand the whole principle behind how they got to the result?
You're questioning my research. I think it's a matter of showing. It answers the question why. Like you're asking why. And for me, it's to give the user the ability to even tell the system that is doing something wrong, or argue that they're not happy. Like, especially for my research where I'm a habit, like I will take the example of TikTok because it's the best recommendation system. It's a mystery how it works, but it works so well. And it's so fast to change based on what you're doing. Like I'm always considering low risk scenarios. So music, point of interest, you don't risk anything. But if you think for finance, where you're like looking to, okay, what stock should I buy? Then you have a high risk because if the recommendation gives you a wrong suggestion and you blindly trust, and then the stock market crash, it could happen even if you have an explanation. Like, I'm not saying that the explanation will solve the problem of the world, but at the same time, you are more cautious of what you're doing and why. And in the case here with the music, it was more towards the fact to use data to connect with a stranger. So you're in the same mood. ABBA maybe was not the best choice, but you're studying for your exam. You can check the history of this stranger, and you see that has never skipped a song for a long period of time. So it seems like it was like some music that can help you stay focused. So you can select, you can see even like why then the songs that appear recommended to you. It's similar to like the daily playlist of Spotify. So why Spotify decided that you should listen? Now they have this dynamic playlist across the day, but why specific song in the morning and not in the evening?
I mean, for me, it's interesting, but if I just think about the regular Spotify user,
Yep.
I don't think they're even that tech savvy to just get what's happening. Why should they understand it? They just want to listen to the next song.
Yeah, like a song is very particular because usually you just play and close everything and keep working. But here it was more like trying to be more engaging with the data and spending time. It's like a lot of my research is based on the principle of the data humanism. So trying to engage people even that are not tech heavy with the data. Was the
I think that's my question.
okay? Yeah.
Last question. Let's switch over. You have to turn off your.
Yes.
Go ahead. You
Yes.
can do two things at once.
Yeah. Okay.
And turn off the mic.
like this student has manually labeled the 10 years of data. So there was like trip to LA. So there was this kind of marking that maybe he was driving, was doing a road trip. But we, like, since Spotify does not collect this data, it's always up to the user to contextualize.
Very good. Thank you, Ibrahim. I want to give you just a couple more minutes, then we'll do the last question, okay? So Ibrahim gave you, I think, a really nice overview of explanation, some methods, some use cases, and I want to talk about one use case in particular, which is you're a patient, you're talking to the physician's going to give you an explanation. And as he said, register is this notion that you tailor your speech depending on what you think the hearer can understand. And that's a function of many things. It's a function of time, what you think they understand, how they are. So in physician-patient conversations, roughly the first third of the conversation is register setting, trying to figure out what you know, what you don't know. Let me tell you another thing about conversations. When the physician tells you, "I'm sorry, Bob, you have cancer," what happens is that immediately your brain turns off and the next 50% of the conversation is not heard. So if you're giving an explanation for why you have cancer, you're just talking into the void. You're wasting your time. So you have to say something to keep the conversation going. But be aware as a physician that your explanation is dropping into the bit bucket. Explanations from humans take into account all this kind of stuff. So a good explanation is one that takes into account what the hearer can understand. So there are lots, I'm going to skip forward here. I have a whole lecture on this, but I don't want to repeat what Ibrahim just did. I do want to skip up to this one, though, and to say that an explanation is not merely a property of a set of sentences. It's not merely the property of a display. It's the interaction. It's the interaction between the system trying to tell you how this thing works, what's interesting about it, what's going on. So what counts as an explanation depends on what the user needs. So you should take away from this. Any system that gives you a canned explanation is not really giving you an explanation. They're giving you an excuse. It's not the same thing. Here, for example, is a paper from Kai from last year, which shows 6 different explanation systems for medical diagnosis. The upper left, the A example, is basically showing you numerical explanations. I'm sorry, numerical explanations doesn't make any sense to me, right? It's not an explanation. It's the explanation is the physician talking to you about each of those numbers and saying why this number is high and it's okay. Okay, and then you see Ibrahim talked about the rule, the model tree, the decision tree. So we've got a decision tree here with telling you which rule was invoked, and that's getting a little bit better. It's actually telling you which rule in the AI system was used. That's good. A little bit more LLM-based text stuff. Probably better are the text plus plus the media. So, for example, the actual X-rays, the imagery. So this is what Ibrahim was talking about with respect to multimodal explanations. This is the future. If you're going to do research, this is probably where you want to be. One last thought, then we'll skip to the final QR code. When should UX get involved in the explanation business? Everywhere. Because what happens is that we have this whole process of developing the system, and if you don't bake in explanation capability from the beginning, it's too late. It's a little bit like privacy and security. If you don't start right at the beginning, it's too late. So you have to have this involved everywhere. And I want to leave you with this thought, which is, this is one of the papers in the reading list. I recommend it to you. It's not a long paper, but I want to highlight this point. Consciously or not, deliberately or inadvertently, societies choose structures for technologies that influence how people work, communicate, travel, consume, and so forth over a very long time. So you're making commitments that will influence you and society for a long, long time. Let me jump forward here. So an interesting problem for us as researchers is how do we express the goals for these different AI systems? So it's one thing to express a goal and another thing for the AI system to say, oh, how does it actually implement what your goal is? Tell me how what your behavior was, you, the AI system, what your behavior aligned with my goal, and give me that story. Give me the story, which is the behavior of the system and how I interact with that. So I want you to think about that. How do we design these things for great multimodal explanations? Okay, there's your QR code for the day.